Hi guys, what's up? Today in series of discrete mathematics, we are going to discuss tree method. Tree method is very useful in solving questions which are used to prove it is tautology or valid or not. So let's get started with today's lecture. Tree method. It is used to find if given composite proposition is tautology or not. There are 4 steps in tree method as you can see. First step is we have to take the negation of the given composite proposition, and then we have to reduce the proposition and make a CNF of it, conjunctive normal form of it. Then we have to make a tree which we discuss later, and if we see and observe if every branch of tree is closed, then given proposition is tautology. For understanding what is a closed or what is a open tree, let's take an example. Suppose we have a conjunctive normal form as A and B and negation of A or negation of B. You can see that it is in a conjunctive normal form. For making a tree, we have to make the parent node as a single sum term which are A and B. So we make it on parent node. Then we have to make child of parent node, and here we have a sum term, so we write sum term as a child of the parent node. Now we see here we have A and here we have negation of A, so this branch is closed, and here we have B and here its child is negation B, so this branch is also closed, so it is a closed tree. Let's take an example of an open tree. For example, if we have A and B and negation of A or B. Similarly here we have to make parent node the single product term which are A and B, and now we have to make child of this parent node, and the child of the parent node is the sum term which are negation of A and B. Here we can see that A is closed by negation of A, so this branch is closed, but B is not closed here, so this tree is not closed. So if a tree is closed, the given proposition is a tautology, and if the tree is not closed, the given compound proposition is not a tautology. Now here we have a question as implies R, whole implies R implies S. We have to find if this composite proposition is tautology or not. According to tree method, first we take negation of our whole question. After taking negation, we have to reduce our answer into conjunctive normal form. So we use our previous rule and reduce S implies R into negation of S or R. we further reduce it using the same rule. For rules, you have to refer to my previous video. Here, by further reducing it, by using double negation law, we get negation of S or R, and by applying De Morgan's law, when this negation interact with this or, it become AND. So here we have our conjunctive normal form. We have three sum terms which are this, this, and this. Now we have to make tree. The sum terms which are single is on the top node of the tree. Here we have R and negation S as a single sum term. So we keep it on top. And then we have to make two child of it, which are other sum terms, which is this. Here we can see that our tree is not closed. A tree is closed if we have here R and negation R on one of its child. So here it is not closed, and here it is also not closed. So the given proposition is not a tautology. So here is another example. So let's start solving it. First we have to take negation of our whole term. After taking the negation, we have to reduce this equation into conjunctive normal form. For this, we use P implies Q, which is equivalent to negation P or Q. After simplifying it, we get a conjunctive normal form. Now we have to make a tree of it. The parent node of the tree is the single sum term, which is P and negation R. Now we have to make child of the parent node, which is either one of these two equations, these two sum terms. So let's take this sum term. The child node get break on OR symbol. So we have two child negation P and Q. Here we can see that P is closed by negation P. So this branch is closed. but this branch is open. So now we use this sum term. Now we can see this negation R term is closed by this R, and this Q term is closed by this negation Q. So our tree is closed. So this compound proposition is a tautology. Here is another example. We have to check this statement is a tautology or not. So here we take P as if it rain and Q as match will play. We can deduce that if it rain, match will not play. It means P implies negation of Q. The second statement is it is rain. So we have only to write P, and we have conclusion match not play. Therefore we write negation Q in the conclusion. So for making a tree of it, we have to make conjunctive normal form of it. First step is to take negation of the conclusion. So our three statement will become P implies negation Q P. Now from this we can write a conjunctive normal form. For writing a conjunctive normal form, we have to reduce this statement, which get reduced it into negation P or negation Q. Now we have to simply write the three statements consecutively separated by AND operator. That is, so here we get our conjunctive normal form. So let's make a tree of it. First we have to make parent node as P and Q. Then we have to make child of it, which are the sum term, which is negation P and negation Q. So here you can see that P is closed by negation P and Q is closed by negation Q. So both the branches are closed. So it is a tautology. Now this is our last example. Here we can see that we have a question which have first statement P implies Q, next is P implies R, the third one is R, and the conclusion is negation of P. For proving this is a tautology or not, first we have to convert it into a conjunctive normal form. So we reduce the first step as negation P or Q, the second step as negation P or R, third step we can write as it is, and the conclusion is negation P. Now we have to take negation of the conclusion, so our statement will become negation P or Q, negation P or R, and we have to take negation of conclusion, so it is P. Now we can write a conjunctive normal form of these statements. So for writing a conjunctive normal form, we write all the statements separated by AND operator. Now we have to make tree. For making tree, we have to make parent node as the single product term which are R and P. After this we have to make child of it. We take this sum term, so we write negation P and R here. This branch is closed. On this branch we take this sum term, negation P is go here, Q goes here. So here we can see that this P is get closed by this negation P, so this branch is closed, but this Q is not get closed, and both of the R is also open. So this branch is open, here it is not closed, so this compound proposition is not a tautology. So friends, if you find this video helpful, please like, comment and share this video with your friends, and don't forget to give your feedback and subscribe to my channel. Thank you. See you next time.